Good day, grade 9s, and welcome to mathematics. Today we will be looking at graphs with limitations. Before we actually look at the graphs, let's do some theory. Natural numbers are numbers that start with 1, 2, 3, and 4. That is things we get in nature. You don't get half an elephant, so therefore we start counting them with 1, 1, 2, 3, 4 elephants. Then we have our whole numbers. Whole numbers are numbers that start with 0, 1, 2, 3. Whole numbers include our set of natural numbers. After whole numbers, we get our integers. Integers are all our whole numbers with the negatives as well. So all our whole numbers are included in the integers, but now we've got the negative numbers as well. Integers does not include halves and quarters and so forth, so the numbers between -3 and -2 are not included in this set. Next, we have our rational numbers. Rational numbers are numbers that can be written as a fraction, as long as you don't divide by 0. So rational numbers are all numbers that you can write as a fraction, except when you write it as over 0. So as soon as you write over 0, it does not qualify as a rational number, but then it qualifies as an irrational number. So rational numbers are the opposite to irrational numbers, and irrational numbers cannot be written as a fraction. They are never ending and they are non-repeating as decimals. Therefore, it is numbers such as 0,17924373959. So there's no pattern in the decimal numbers. Okay, that is our rational numbers. And then the most important one of all of them are our real numbers. Those include all our rational and our irrational numbers altogether. These are all the numbers on a number line. Therefore, if we draw any number line, the numbers that are represented on it are real numbers. The only set of numbers that are continuous are our real numbers. They are the only continuous set of numbers, and they can be drawn with a solid line on a graph. This only applies to real numbers. Please remember that. Then we get two other sets of how our restrictions can look. The first one is around brackets like these, and they indicate that the limits are excluded from the graph. So just remember, around brackets means excluded from a graph. And then we have our square brackets like these, which indicate that limits are included on the graph. Please don't confuse these set of round brackets with the way we write our coordinates. I know coordinates are also written with round numbers, but they are written with an A or a B in front, whereas this specifically applies to our limits. Let's put these on graphs. So all our information that we've just gone through, let's apply it graphically now. So we're going to do these on number lines before we place them on graphs. So the first one I want to do looks like this. We are working here with real numbers, so we know it's a solid line, and our limit goes from larger than equal to -4, smaller than 4. So if we draw a number line, we know we're working between the -4 and +4. We know that -4 is included, therefore we can make a solid dot. 4 is excluded because it does not say it is included, therefore this one is an open dot. We know this is real numbers, therefore we can connect these two dots with a solid line. Let's do another example. Here we are working with integers. So if we work with integers, we're working with all the numbers that we can actually see on a number line. We do not work with the numbers between the actual digits. So in this case, we are working from x larger than -2, so -2 is not included, open dot circle. We are going smaller than or equal to 3, therefore at 3 is included, therefore it's a solid dot. Now we go from left to right. -1 is an integer, solid dot. 0 is an integer, 1 is an integer, 2 is an integer. So now we've got our dots. Now we're looking at our limitation, our set of numbers, we are working with integers, so we are not working with the numbers between -2 and 1. Therefore, this is our final answer. Let's do another example. And this time we're going to work with natural numbers. Natural numbers are things that we can find in nature, therefore it starts at 1. 1 koala bear, 2 panda bears, not half an elephant, if you remember. So graphically we start at -4 and 4. So if we look at -4, it says that -4 is included. However, -4 is not a natural number, therefore we have an open circle. If we look at 4, which is our other limitation, so 4 is excluded on this side, however it is a natural number, therefore it's still an open circle. Now we know that we are working between these 2 points, so let's go from left to right. Is a -3 in this set of numbers? Yes it is. And is it a natural number? No it is not, therefore it's an open circle. -2 falls between these 2 points, however it is not a natural number. -1 also falls between these 2, but it is not a natural number. 0 again falls between these 2 points, however not a natural number. 1 falls between these 2 points, and it is a natural number, therefore it's a solid circle. 2 is a natural number and it falls in bounds. 3 is a natural number and it falls in bounds. So there is a numbers represented by this. So is the numbers between -4 and -3 included in natural numbers? No, therefore it is not a solid line because it is not real numbers. Our next set of numbers looks like this. This is our whole numbers. Whole numbers are all natural numbers and includes 0. So if we represent this graphically, we're looking at between -3 and 4. Let's start at -3. -3 is definitely included in this graph, however it is not a whole number, therefore it's an open circle. 4 is definitely included in this, it's not equal to, but it is definitely a whole number, therefore it's an open circle because it's not applicable on the side. Let's know all the numbers that we're looking at are going to fall between these 2 circles now. So let's analyze them. -2 is between -3 and 4. Yes. Is it a whole number? No, it is not. Open circle. -1 is also not a whole number. 0 is a whole number and it falls between those 2. Therefore, it's a solid circle. 1 is between those 2 points and it's a whole number. 2 falls between those 2 and it is a whole number. 3 is also a whole number and falls into bounds. Therefore, this is the graph that we're looking at. Again, it is not a set of real numbers, therefore it's not a solid line. Now let's do this on our actual graphs. First, we're going to use a function. This is a function 2/3x minus 4. 4x larger than equal to -1, smaller than 3. So this is how we're going to set up our table. Our table is going to start at -1 and it's going to end at 3. -1, 0, 1, 2, and 3. So now we look at our equation. We substitute our x values into x's place and we're going to get all our y values. So our first y value is -4 and 2/3. Our second y value is going to be -4. Our third value, where x is 1, is going to be -3 and 1/3. And the next one, where x is 2, y is going to be -2 and 2/3. And our next one is where x is 3, then our y value would be -2. Now we have our fully complete table. Let's move on to actually drawing it. So there we've got our table. Before we actually put this on the Cartesian plane, let's again look at our equation and our limits. So this was our equation and this was our restrictions. X larger than or equal to -1. So if x is -1, it is definitely included in our set of values. Therefore, negative 1 will be a solid dot. I do this before I even look at my graph so that I don't get confused later. Is x between these 2 points as if it is a 0? Yes, it is. Therefore, it is a solid dot. Does 1 qualify in these 2 limits? Yes, it does. Therefore, solid dot. 2 also, yes. And 3, is 3 included? No. X is smaller than 3, but it is not equal to 3. Therefore, it's an open dot. Let's put this on the Cartesian plane. Here we go. We start at negative 1 and we're going to end at 3. So this is the place where our graph will be. So let's put these points on. So negative 1, negative 4 and 2/3, 0 and negative 4, 1 and negative 3 1/3, 2 and negative 2 and 2/3, 3 and negative 2. Remember, it is an open dot, therefore open dot. Now again, we look at our limitations to decide if it's going to be a solid line or not. There is no further definition of numbers. It does not say that which set of numbers it belongs to. Therefore, we can assume it is a real numbers, and therefore we can draw a solid line between these points. Okay, let's do another. And this time we have an equation that looks like this. 8x plus 2y equals 6. Before we actually do something with this, we need to write it in standard form. So a simple equation would be to simplify it into standard form where it is y equals 2. If we look at the equation they've given us, we can see that 8, 2 and 6 are all multiples of 2. Therefore, we can divide both sides by 2. If we divide both sides by 2, we get 4x plus y equals 3. Now we just need to get rid of this 4x because y is already on its own. So 4x minus 4x on both sides. Therefore, we have y is equal to negative 4x plus 3. Now that we've got our formula in a standard form, we can now take our x values and substitute it into our table. So again, there's our table. We're looking at negative 1 and 2. Negative 1, a round bracket, there, a 2 solid, positive 2, round bracket there. So this is our points for our table. So now let's substitute our values for x into our equation. So negative 1, therefore a y would be 7. If we look at x as 0, then y would be 3. If we substitute x as 1, y would be negative 1. And if we substitute x as 2, then y would be negative 5. Next part, there is our table. Let's look at our restriction. Our restriction now has round brackets. Round brackets means the numbers are excluded from our range. Therefore, negative 1 is an open circle and 2 is also an open circle. The rest would be solids in between. Let's place these points on a Cartesian plane. We're working between negative 1 and 2. Let's place them. Negative 1, x is negative 1, y is 7. X is 0, y is 3. Now when you do this, take into consideration the dots that you made at the top so that you don't make the wrong ones. Negative 1 and 1, positive 2 and negative 5. There are our 4 sets of coordinates. We know no more, we don't know to which set of numbers they belong, but we can therefore assume that it is real numbers and therefore we can combine them with a solid line. So that basically sums up everything to do with graphs. I hope you understand. Please comment on this video if you like it and let me know what you think. Have a super day.